Alright, let's take a look at a few more examples with our concept of distributive property and keeping in mind our whole analogy of this idea of the grocery bags. So here what we have, if you read this equation the correct way, is 3 times parentheses, and inside the parentheses 2x plus 4y equals 66. And what we're focused on over here is this part, the parentheses, which once again is like thinking of these parentheses as a container or like a grocery bag. The number in front, the 3, is telling us how many of these exact bags we have. So what this is telling us is there's 3 bags. Each of those bags is filled up with 2x plus 4y. So if we can visualize that in our heads, we can see what's going on with the distributive property. And the reason why it's called the distributive property is because we're basically distributing this multiplication. We know we've got 3 of these, and we've got 3 of these. And so by distributing that multiplication of 3, we get our answer. So in this case, 3 bags, each with 2x in them. Well, 2x and then another 2x and another 2x, or 3 times 2x is 6x. Plus, now once again, those same 3 bags, but each bag containing 4y, 3 times 4y would be 12y. And then this side of the equation we don't concern ourselves with. The equal sign's kind of like a barrier in between. We can't cross over it. So we're only focused on this part here and simplifying it so that we get 6x plus 12y and no parentheses. And so when a problem asks us to simplify, this is one of the things we're trying to do. Just like our groceries, we always first take things out of the bag. Alright, let's take a look at another example. So here we've got another equation that eventually we'll solve, but for now we're just simplifying. 2 times parentheses 7n plus 4 equals 3 times parentheses 4n plus 12. So once again, all we've really got here is I have on this side of the equation 2 grocery bags, and contained inside each grocery bag is 7n plus 4. And now even though 4 is a regular number, just think of it as another item. Maybe it's like a $4 rebate inside the bag. Over here we've got 3 bags, but these 3 bags contain something different. 4n plus 12. Well, again, if we just visualize things, here we have 7n in each bag, and there are 2 bags, so 2 bags with 7n each is 14n. Those same 2 bags with 4 in each one, 2 times 4 is 8. Now let's look at these other separate bags over here. 3 bags this time, and in each bag 4n plus 12. So all we have to do is distribute that multiplication. 3 times 4n is 12n, and then 3 times 12 is 36. So once again, we simplify things by taking things out of the parentheses or out of the grocery bags. 14n plus 8 equals 12n plus 36. Alright, one more example. Now, for this example, this is where we want to start getting away from our grocery bag idea, because with algebra, of course, we're not always going to stay with positive numbers. Sometimes we're going to deal with negatives. And it's a little hard to visualize what a negative number of grocery bags would be. So at this point, we want to stick more to the idea of just pure distributive property. And so what we have here is negative 3 times our container, our parentheses, and inside those parentheses is contained 5x minus 9. Again, the other side of the equal sign we're not concerned about. So what we're going to do here is we're going to distribute this multiplication. Negative 3 times the parentheses, which means if we do it piece by piece, it's negative 3 times 5x, which would be negative 15x, and negative 3 times our minus 9. And I could go through all the steps here, but it's probably easiest to think about it as negative 3 times a minus 9. And with a lot of the different ways we've learned multiplication, the bottom line is that when we have a negative times a negative, or in this case a minus, it becomes a positive. So negative 3 times a minus 9 will actually become a positive 27. And once again, we've achieved our goal. We've gotten rid of the parentheses and cleaned up our equation a little bit. So this is the basic idea behind distributive properties. So what you're going to see next is some problems which you're going to try to apply this information and see if you can't simplify these problems.